Thank you. My name is Timothy van Herbergen, and I am the CTO at Triangle Factory, which is a small game development company that was founded in 2010. And I'm going to do a presentation about coding an XNA game in 50 minutes. So first I'm going to talk a little bit about myself. I'm 26 years old. I studied applied informatics here in Antwerp, and then after that I went to do digital arts and entertainment in Kortrijk, which is a course that's more aimed towards game development and interactive 3D, because I actually didn't want to write business software all my life. So I wanted to do something more creative. And now I'm technical director and founder of Triangle Factory. And Triangle Factory was founded in January 2010. And it's founded by three Microsoft Imagine Cup 2008 finalists. So we entered the Microsoft Imagine Cup 2008 in the game development category. And we got second prize there, so that was kind of a boost to launch our own company. And Triangle Factory delivers services in game development for multiple platforms like PC, mobile, console. And we also do interactive 3D visualizations where we try to use game technology not only for games but also for other businesses like product visualizations or educational games, things like that. And then we also do content creation if someone wants to outsource their content to another company. We make 3D models and things like that. So I'm going to talk a little bit about XNA. Probably most of you already know what XNA is. For those who don't, XNA is a free tool set for game development. It integrates with Visual Studio 2010, and you also get Visual C# 2010 Express with it. For free, so you can start developing for free. It uses C# and the .NET framework, and it's actually used to develop for multiple platforms. So you can develop your games only once and then start porting them to other platforms like Windows PC, Xbox 360, or Windows Phone or Zune. It has a really large community, the App Hub, which is really interesting. If you want to see a lot of samples or tutorials, you can find that there. And then we have the Xbox Live Indie Games, which actually is really interesting because if you make a game yourself, you can release it and you can even earn money with it. So everybody that wants to do that is able to do that. Although you have to pay a small license fee, I think it's about $86. That you have to pay if you want to deploy your games to Xbox 360 or Phone 7. But for the Windows version, it's free. So I'm going to go directly to my demo because we don't really have that much time. Actually, what we're going to make is an asteroid game. Probably most of you know what kind of game Asteroids is. So we boosted the graphics a little bit, and we're actually going to deploy this on a Windows Phone 7. So first of all, because I need to go quick, I already have a lot of classes that I already made that I'm just going to put in the project, but I'm going to go over them and just explain what I'm doing. So first of all, we're going to create a new project. And we're going to choose Visual C# XNA Game Studio 4.0. And we're going to build a Windows Phone game 4.0. So we'll give it a name. Let's call it Space Shooter. And we'll just press OK. Oh. Okay, and then you'll notice that Visual Studio will create two projects. One project is actually your game itself. And then we have a second project which will be used for all of the content. So it's the content pipeline project, and all of our images and stuff like sounds that you want to use in your game, you're going to put them there. So first of all, I'm going to put all of my content into the content folder or content project. So as you see, most of these are images, or there's also a font. And these are all the stuff that we're going to use in our game. So I'm not going to make a 3D game because it's actually we don't have a lot of time, and it's a little bit more complicated to make a 3D game. So we'll just keep it 2D. And as you can see now, I have all my content in my space shooter content project. And then we'll start with our main game class. This is actually the base of an XNA game, and it's one of the most important classes of your game. This is where you're going to do everything. It has your update, your draw calls, and so on. So first of all, we're going to rename this to Space Shooter Game. And then we'll say yes. So, and first I'm going to go over this class so that you know what it's needed for. So first of all, this is actually your main class, and it will just it has a constructor, it has a graphics device that we'll use for drawing to the screen. It has the link to the content folder so that it finds all of the content that we've put in the content project. It has initialize where we'll initialize all of our game code. And then it has a load content and unload content. These are functions that we will use to load the 2D images and sounds and stuff like that into the memory so that we can use them. And then we have an update. This is actually one of the most important methods that we'll use. And this update is called multiple times every frame and just is needed for updating all of our game logic. So it's quite an important function. And then we have a draw method that we are going to use to render everything to the screen. So I have my Windows Phone 7 here, and let's just start and deploy this to the Windows Phone so that we see what we're getting. Okay. And I'm going to show you that now we haven't done anything, but I'm going to show you what you get if you just start a new project. So. Okay, it's not doing anything. So this is actually a blue screen that we get because we haven't done anything. So it's not very much, but of course we haven't done anything. So what we want to do first, we want to draw a background of our space so that we have something more nice than this blue screen. So as you can see, in the draw call, the only thing that's been done is graphics device.clear cornflower blue. So that's actually the color that we're seeing now on our device. So we'll want to change this, and we'll want to show a background. So what we'll do is create a new variable, and we'll call it. It's a texture 2D value, and we'll call it background. And then in the load content, which is automatically called when the game starts, we'll want to load this background. So we'll load it through the content pipeline. So we'll just say content.load, and then we'll give the type that we want to load. It's a texture 2D, so we'll load it as a texture 2D. And then we'll give the string of the asset name, how is it called. So we don't have to put the extensions there, so all we have to do is background, and then it would get loaded. And then we want to draw it. And what we need to for drawing the background to the screen is a sprite batch. As you can see, the game already has a sprite batch. And the sprite batch is actually something that's in XNA helps you to draw 2D stuff to the screen. So if you want to draw something in 2D and you call the sprite batch.begin, then XNA will tell the graphics device that it wants to draw 2D images to the screen, so it prepares it to the graphics device to draw these things to the screen. So then we can start drawing something, and then we can start drawing our background, which is the background, okay. And then you can give a position of the background, so we'll start by giving it in the 0 upper left corner, which is 0.0. And then we'll give it a color, but actually we don't want it to add a color to it, so we'll just give white. And then after we've done drawing our 2D images to the screen, we always have to call sprite batch.end. All right. Now if we deploy this, we will get a nice background on our game. So, as you can see, now we have a space background, but that's not very much. So we'll still have to add a lot of stuff. And then we'll start by adding all of the classes that I already made in advance, because otherwise it's going to take a long time before we get our game. And I'm really bad at multitasking. So, okay. So first, what we first want to have is a basic class that actually represents every object in our scene. So basically in asteroids, when an object gets to the side of the screen, it just goes to the other side of the screen and comes in back there. So what we want to do is actually have the same behavior for every kind of object in our game. So the first class I'm going to discuss is this space object class, which actually has a space bounds, which is just a rectangle that says, okay, this is the game limits. So we have the resolution here of the Windows Phone 7. Then we have a sorry. So we have this space object. I added the classes here. So we have this space object. This is the most important class in our game. And the space bounds are needed for the object to know if it's on the side of the screen. Then we have a position for every object, which is a vector 2D. We have a force, so that if it's moving, that it has a force on it. It has an origin. This origin is used if we rotate something. Then it's always around the origin that we rotate. So we'll have to calculate the origin because we want objects to rotate around their own center point. So we'll actually calculate this based on textures. Then we have a rotation force, a scale, which is used to scale images if we want them bigger or smaller, a collision radius, which we'll be using for collision detection. If another object hits another object, then we'll just calculate it by using sphere collisions, which is really simple actually, because if you use circular collisions, you'll just have to, I'll just explain that later, it's really easy actually to calculate collisions with that. And then we have a texture asset and the texture we need to draw the object to the screen. So then we have some properties for everything. And then we have our constructor where we just set the basic stuff that we need. And then in our load content, we'll just actually load the texture that is used for drawing that specific object. And then we'll calculate the origin, so the point on which we'll want to rotate, by just dividing the width of the texture and the height of the texture. So, and for the collision radius, we'll just divide the width of the texture so that we have actually a circle inside of the rectangular texture. And then in the update of our space object, we'll just add a force to the position of our space object so that the position always gets updated every time with the force that is applied to the object. And then we'll have a rotation, and we'll also add rotation force to that so that the rotation also gets updated with the force of the rotation force. And then we have a little bit of code here that's actually just calculating if the object is on the left of the screen or the right of the screen so that it gets transferred to the other side of the screen. Then we have the draw calls, and these draw calls are a little bit different than drawing our background. The reason why they are a little bit different is because they don't have the sprite batch.begin and .end, so we'll have to do that somewhere else. But the reason why I do that is that I don't want to be changing the state of the graphics device constantly. If I would do that, then it would be really bad to render everything, because then the graphics device would constantly change state from 2D to 3D, and then we would have a problem in performance. So that's the reason why I don't call spritebatch.begin and .end in these draw functions. I'll be drawing actually all of the objects, the 2D objects at once, so that I don't have to switch states. Then I have this collision method that I'm calling, which is actually also in a space object, and it just checks if it's colliding with another space object. So basically what I do here is, if you have two circles and you take the center points of those two circles and you calculate the distance between those two center points, then you know if the distance between those two center points is smaller than the sum of the radius of those two objects, then you know you have a collision. It's actually basically really simple, and it's also a really performant way to do collision detection. If you will constantly be using circles, then you might say, okay, it's not really correct because not every object is a circle, but most of the time it's nearly correct and people won't notice, so it's good enough. So this is actually our base class that we're going to use for all of our space objects. So first of all, we're going to need a player, and that player will be able to shoot and be able to fly around. So based on this space object, we're not going to really inherit from it, but we're going to encapsulate it. So we're going to make a player which has a space object, which is the spaceship, and has a bullet manager. And this bullet manager is basically something that is basically a list of bullets that we're firing, and it just destroys them in time. So I'm going to show the bullet manager. So basically we have a list of space objects, because a bullet is also a space object, and we'll be creating that list, and every time we update, we'll just check how long our bullets are alive, and if our bullets are older than 1.5 seconds, we'll just destroy them. So we'll remove them here. This remove function is actually a helper that I made, because the list.removeAll function in XNA actually doesn't work, so you have to make your own. So these are helpers that I have right here. So a simple helper that I made to remove those things from my list. And then we have a method called fireBullet that's just for our spaceship to call, for our player class to call a method so that it can fire a bullet so that it adds a bullet to the bullet manager and fires it and adds a force to it. So that's just for firing a bullet, actually. So then in our player class, we'll go on with our player class, we also have a sprite batch, and what I forgot to mention is actually that our player class is a drawable game component. So in XNA, you have game components, which is really interesting, because you can easily add game components to a game or remove game components to a game, and the advantage is the drawable game component has a little bit the same interface as the main game class, so it has an update, a draw, a load content, and initialize, as you can see here. So this is the update, this is the load content, the initialize. It actually has those same methods. And if you add a game component to the game class, these methods will automatically be called by the game, so you don't have to handle this for yourself, which is quite nice. And you can easily add or remove game components anytime you want. So that's why I'm making this, and this is a drawable game component. So you got two types of game components: drawable ones and non-drawable ones, so normal game components. And the difference is only that a drawable game component has a draw method that's automatically called, and a normal game component doesn't have any draw methods. So that's for components where you don't have to draw anything. So our player is actually going to be a drawable game component, and except for the sprite batch and we also have a thumbstick that we're going to use to display. It's actually a texture 2D that we're going to use when we're moving the spaceship. So we're going to implement some virtual thumbsticks. And these thumbsticks are actually a sample that I got from the App Hub. So it's actually a free sample that you can download. And all that it does is actually, it's a static class that you can use to check if there's somebody pressing on the left side or the right side of the screen. So you got two thumbsticks, a left thumbstick and a right thumbstick, and all that it does is actually check if there is any touch, and if there is touch, what's actually the distance that you're away from the thumbstick. So it gives you values like an Xbox 360 thumbstick controller or whatever. So it's really easy, and I mean it's free. You can download the sample for free. So why do you have to do that extra work if it's already available? So. So I'm using these thumbsticks in the player class for eventually doing the input. Then we have a sprite font and a score position and a score. That's how for drawing the score of the player when we're playing the game. And then we have a sprite sheet, an explosion. And this sprite sheet is actually a class that we're using to display animations in 2D. So 2D animations are a little bit different. And how 2D animations work is actually, we have a sprite sheet. I'm not going to explain this class completely because we don't have that much time. But what this class basically does is I'm going to show you the explosion bitmap. So basically what it does is these are all of the frames that an explosion has. So the way that we make an explosion and show these frames is actually we're going to cut these images out of this big image and actually display it all at the same position and just going to do one frame, next frame, next frame, next frame, next frame, and actually going to go through all of these frames so that we have an explosion. And if you draw it in a frame rate after each other, then you just get an animation actually. So that's how animations mostly are done in 2D games. And this sprite sheet class is actually a helper class that helps us to draw these animations. So we'll actually just saying to the sprite batch, okay, just draw one part of that image, and then the next update will just change the part of the image that we're drawing and change it every time. So we'll have this sprite sheet in the player class because we'll need it when the player explodes when hitting an asteroid. And then we have some variables that we're using over time. So if we're respawning, if we're blinking, if we're destroyed or not, if we're respawning, and then a spaceship color. So we have some properties for these methods, for these variables. And then we have a constructor where we basically create the player and initialize all of the variables that we need. We're actually putting the player in the middle of the screen when the game starts. So we're calculating the necessary position for that. And in the load content, we just create the sprite batch. We create the texture for the thumbstick. We create the texture for the score font. We load the score font, and we load the content for the spaceship, space object, and for the explosion sprite sheet, so that everything gets loaded what we need. And then in the update function, we'll actually be using these virtual thumbsticks, and we'll just be asking the right side if it actually has a value, and if it has a value, we'll see if this value is big enough to actually have some movement. And then we'll be calculating a new force. So this force will actually be the direction of the thumbstick. So as you can see, I'm just using this direction of the thumbstick, the X and Y direction of the thumbstick, to get a force. And then we'll normalize that force because we want to change how big this vector is. I don't know, probably know what normalizing is, just that it has a vector, that it's a vector of a length of 1. So eventually the vector will have a length of 1, and then we'll multiply it with 0.2 so that it has a certain amount of force that we're adding. And then we'll add this force that we calculated to the spaceship force, and then we'll calculate the rotation. And for the rotation, we're actually calculating the angle between two vectors. We're calculating the angle between the up vectors, so that's the spaceship's normal state, and then between and together with the vector of the thumbstick. So we're actually saying, okay, what's the angle between the thumbstick and of my spaceship in a normal position? And then we're actually rotating the spaceship with that amount of the angle so that it's in the right angle of the thumbstick. So in that way, it just follows the thumbstick around when you move the thumbstick. Then for the left thumbstick, we'll actually be using this just as a button. You could do this more easily, but since I had the thumbstick class, I just used it as a button, and I just checked if was it previously pressed or not, and if it wasn't, then you'll be able to shoot. And we'll just create a new bullet. We'll add a force. We'll create a vector for that bullet, which is in the same direction of our spaceship. So we'll rotate it using a matrix, and you could rotate it in another way, just calculating the angle and stuff like that. But for me, it's easier just, in my opinion, it's easier just to use matrices. You've probably all seen this in math. So you can actually create a rotation matrix and rotate the vector. Rotate the vector that we created, the up vector, with that rotation matrix so that it's in the right direction. So then we know that's the direction of our bullet force. And then we'll just create a bullet and we'll just ask the bullet manager to fire a bullet. And the bullet will start from the position of our spaceship and it will have the bullet force that we calculated before that. So then we'll have to limit our force of our ship, because if we add force to our ship and we're never going to limit it, it will eventually go limitlessly fast, so we won't want to do that. So eventually we'll just limit it, and we do that just by normalizing actually the force of our spaceship and just multiply it by 10. So our force vector will always have a length of maximum 10. So in that way we are sure that we'll never go faster than 10. And then we're going to add some friction. If we're not moving anymore, we want the spaceship to slow down. Eventually in space you don't really have friction, but we'll just do that because it makes it more fun. Otherwise you won't stop moving when you're moving around with the joystick. And then we'll call the space object print update, because we're encapsulating the spaceship. We still have to call its update because it's not a game component, so it won't be called automatically. So that's a space object that we created. And then we have a function that checks if there is if there should be an explosion or not. For example, if the player is hitting something. So we're using this. This is actually set somewhere else. If the player is destroyed, we'll be playing an explosion, and if the explosion is still playing, then we'll update the explosion. If not, then we'll just reset the spaceship to its original position. This is something that we have for blinking. If we want the spaceship, if the spaceship is destroyed, we want the player to be blinking so that he knows that he is not alive actually at that moment and he can't be hit by anything else. And then we have then we'll just check the state of the left touch button, because actually that's a button when we're shooting, and if we would hold it, we don't want the player to be shooting all the time. So we'll actually just want to check if the left thumbstick was already pressed last time or not, and if it was already pressed, then we're not shooting. If it actually was released last time, then we're going to shoot. And then we'll call the base update, which actually calls the base update of the drawable game component. Then we have the draw, and like I told you, we're not going to call the sprite batch.begin and end for every space object. So here you'll notice that I'm calling the sprite batch.begin. Then I'm starting to draw all of the bullets that the ship has shot. So I'm going through all of the bullets of the bullet manager and just drawing it. And then it might have been cleaner if I just made the bullet manager that it also had a draw function, but I eventually didn't do it. Then we're drawing the spaceship itself or the explosion, depending on the spaceship is destroyed or not. So if we're still alive, then it will draw the spaceship. If we're exploding, then we'll draw the explosion sprite sheet. And then we'll draw the thumbsticks. If they are pressed, we'll draw a little image so that we know where we actually pressed. So it'll show up where we pressed. So that's just using the sprite batch also. And then we draw our score, which is actually added when we hit something. We'll add something to the score, and we'll just show a little bit of text where we know what kind of score we have. And then eventually we call the sprite batch.end. So all of this is actually drawn in one sprite batch call, so which it actually makes it really performant. Basically, most of the time, if you make a game, you'll probably want to make the game in that way that there is some kind of a renderer class that renders everything in one call, so that the graphics device doesn't have to change in any state. So that makes it a lot more performant when you draw something. So then it actually doesn't matter that much how many objects you're drawing. It just matters how good your graphics card is then. So if you would draw everything separately, then the CPU would get a bottleneck. And otherwise, if you would do it the other way around, draw everything in one batch call, then the graphics card would actually become the bottleneck. And your graphics card is better in drawing everything at once, so it's better to do it that way. Then we have a respawn function, which is just called when the spaceship is destroyed and we're actually respawning. We'll just reset the position. We'll set the force to 0 so that you're not moving anymore, and we'll reset these bools, and your score will get reset to 0. So now that we have this player, we'll want to add it to our game. So we'll go to Space Shooter game, and the first thing I'm going to do is actually set the graphics device, because we're actually always playing in landscape mode, so we want to make sure that the game is always in landscape mode. So what we'll do is we'll add a supported orientation, and we'll just only add landscape left. So that means that the game will always be in landscape mode, which is good to know, because otherwise if the player would change it, your coordinates would change. So that's kind of awkward when you're making a game and the coordinates are constantly changing. So eventually we want to make our player class, so we'll do that in the initialize. So we'll make a player and just give our game class with it, and then we'll want to add that component. We'll want to add that component to the game. So we'll just say, okay, this dot components dot add, and we'll just add the player, which is actually a drawable game component. And the cool thing that we don't have to do now is that we don't have to call this update by ourselves and stuff like that. So we can, if we would run this game, we would already have the player in it normally, which would be able to shoot. So let's build this. Okay. And all right, so now we can see the spaceship, and we haven't added any asteroids yet, but as you can see, if I touch the screen, oh, I forgot something. Just a second. I forgot to update my thumbsticks, so that's also important to do. All right. So what we're going to do now is in the update, we need to update our thumbsticks. Thumbsticks are a static class, so they're always available. Oh. Right. So they're always available, these thumbsticks, so we'll just say virtual thumbsticks dot update, and now our thumbsticks get updated. And then we'll run this. Right. Right. Seem to have done something wrong. It's not reacting. Just see. Okay. So eventually we'll have this, and as you can see, where I touch, we have a thumbstick, and depending on where I move, the spaceship will actually be moving, and if I cross the screen, it will just go there. And so that's like in the asteroids game. And if you touch the screen here, you'll be able to shoot. And you see that the bullets get destroyed when they're about 1.5 seconds old. So basically all we have to do now is just add our asteroids, and actually then we'll be done. Okay. So basically what we want to do now is create an asteroid field, but the asteroids have to come randomly, so we'll have to calculate random positions for these asteroids, and we'll want to make them rotate, we'll want to make them move towards a player actually a little bit maybe. Doesn't really depend, the screen is not that big, but we'll just see how we can see now how we can create that. So actually all of our asteroids are also going to be space objects, and what I've created here is actually a asteroid field, which is a class that actually holds all of the asteroids and will actually spawn asteroids randomly in the game, so that the player always has asteroids to shoot. The fuck? Sorry. Okay, sorry. So we have this asteroid field. This is a class that we're going to use to create all of the asteroids, spawn them randomly, and as you can see, we'll have this player class that the asteroid field also knows where the player is located, and that it can actually calculate the collisions with the player. So we'll have to add a reference of the player towards this in this class. Then we have a list that contains the space objects, which actually will represent our asteroids, as you can see. Then we have a then we have a list of explosions, which is actually a list of sprite sheets. So the explosion sprite sheet that I showed you, we're going to use that for our explosions. And then we have a spawn timer, and this timer will be used to check how fast we're going to spawn asteroids. So basically, we don't want all of the asteroids to come at once. We want to spawn them in time, and we'll also want to add asteroids, but only add them like when there are less than 5 asteroids. Add a new one, so that the game doesn't get bloated with asteroids. And then we'll have a random that we create here for calculating random positions. Then we have the player property where we can set the player of the asteroid field. We'll have the constructor where the asteroids lists get made and the explosion lists get made, and the spawn timer is set to 0. In the initialize function, we're not doing really anything. In the load content, neither. The sprite batch is just made, but that's all. And then we'll have a spawn asteroid function. So what we're doing here is actually we're creating a random position. So we're creating a random X and Y position on the screen, and this would actually be something that we're creating it negatively, because eventually the update of our space object will always put the space object inside of the screen, so it will take care of that. So if we create a negative one, then we know that it eventually will always be at the border of the screen. Depending on the force of the object, it will come out on the other side, or depending on if it's a positive force, it might come down on the low side. If it's a negative force, it might come down on the above side, above the screen. So basically, we're just calculating negative positions on the screen, because our space object will make sure that it actually enters the screen. And if we create negative positions, then it will always be outside of the screen that it is spawned. So in that way, we'll make sure that asteroids aren't spawned in the middle of the screen where our player is currently at. So basically, for the direction, we'll actually do the same. We'll just create a random X and Y direction for our force. And we'll do that with -5 and +5, so that it's always a half circle around for y it's the same. For y the same actually. So we'll create a speed, how fast the asteroids are moving. This is needed so that we have some random speed. So one asteroid might be moving fast, one other asteroid might be moving really slow. And then we have a rotation force, because we want the asteroids to rotate a little bit. And then we have a random bitmap map, because we have 4 different kinds of asteroids. You see them here, 1, 2, 3, and we eventually want a random one selected every time we spawn a new one. So what we do here is we just create a random between 1 and 4, so that we have 1, 2, or 3, and then when we create our asteroid, our space object, we'll just say asteroid and just add the 1, 2, or 3 so that we always get one of these 3 and it's always random. So we'll add the force after that we calculated with the direction x and direction y. We'll normalize that force and we'll multiply it with the speed, with the random speed that we calculated here. So eventually we're doing the same here. We're just creating a vector of a 1 length, and then we'll multiply it with the speed so that it actually has the speed that we wanted. Then we have the position that we just set here, that we calculated here, and then we create the asteroid, we'll set the force, we'll set the rotation, we'll load the content because the space object isn't a game component, we'll have to do it ourselves. So we'll load the content here and we'll add the asteroid to the list that we created here above. And then we have the update. So eventually in the update we have a spawn timer which actually holds the time that has passed since the last update. So we're constantly adding this to the spawn timer. And then we'll check if 1 second has passed and there aren't more than 5 asteroids, add a new one. So eventually we'll always have 5 asteroids in the screen, in the game. And then eventually we want to update these asteroids, so the update isn't automatically called for a space object, so we'll have to call it ourselves. We'll update these so that they start moving, and then we'll go and check for collisions. So first of all, we'll check for collisions for every asteroid, and we'll first check if it's colliding with a player. So what we do is we first check, is the player respawning or is he dead? Then we don't want to check collision because we don't want him to die again. And if so, if he isn't respawning or isn't destroyed, then we're going to check a hit between the asteroid and the player's ship. So we're just going to see, okay, are they colliding or not? If this is the case, then we're destroying the player, and we're just setting the properties of the player is destroyed, and the player will handle all of the rest. Then for all of the other bullets, we're actually just checking if an asteroid is hitting a bullet. So we're kind of doing the same. We're just checking, is a bullet hitting the asteroid? So yes, then the bullet is gone, the asteroid is gone, and we'll just add a score to the player object so that we get 10 points for that. And then we'll create an explosion because we want an explosion to happen when the player shoots an asteroid. So eventually we'll create a new sprite sheet, we'll add the explosion, and then we'll position the explosion where the asteroid was. We'll scale it a little bit because it's a little bit small and we want it a little bit bigger for an asteroid. And then we'll load the content for the explosion, call the play function of the explosion so that it starts playing, and we'll add the explosion to the explosions list. And then for all of the explosions, if an explosion has happened, we need to update it. So for all the existing explosions, we're updating this so that the sprite sheet gets updated and it selects another frame every time. And then after we've done all that, we'll be removing all of our asteroids that aren't alive anymore. So I'm using predicates for this. I think it's pretty easy. So basically, we just say to the asteroids list, remove every asteroid that isn't alive anymore. And for the explosions, we're actually doing kind of the same. We're just saying to the explosion list, okay, remove everything that isn't playing anymore. And then all of the explosions and asteroids that aren't active anymore will just get removed. And then eventually we'll have our draw method for our asteroid field. And we'll call our sprite batch.begin here also, only in the beginning. And we'll draw every asteroid that we have in our list. We'll draw every explosion that we have in our list. And we'll call this sprite batch.end when we're finished doing that. So eventually, I'm actually, every render call, I'm actually calling the sprite batch.begin twice. So first of all, for all the asteroids and the for all the asteroids and the explosions, and then eventually also for the player and all of the bullets that he shot. So basically, if you want to even optimize this more, you could make a class that would render all of this at once, so that a class that just holds every space object in the scene, and it just goes over every space object in a draw call and renders this at once. But I separated this because it was a little bit more obvious to do that here. And calling sprite batch.begin 2 times isn't that bad. It only starts to get bad if you do this about 50 times or something, or 100 times. Definitely on a phone, on a phone, it has quite a performance impact. Of course, on a PC or an Xbox, the performance impact is a little bit less because it's a lot more powerful. So basically, we have this asteroid field, and as you can see, this asteroid field is also a drawable game component. So we can just use it just like the player class that we created. And the way that we are going to use this is eventually the same way as a player. Okay, I'll create a new asteroid field. Okay, and then we'll add this component also to the components of the game. And eventually we'll also want to add the player to the asteroid field so that the asteroid field can check for collisions. So we'll do that. And actually we're kind of finished with our game. So I can build this now and show this. Are there some people that need some explanation on something more, then I can still explain this after that. So I'm going to run the game now, and then you can see how it works. Okay. Okay. As you can see, I have asteroids now. If I shoot them, oh, damn it. I have 2 screens at home, but I don't have to press a button for that. Okay, so we'll have to shoot. You can see that you can shoot the asteroids now. They get an explosion. So that's actually the sprite sheet that you see in action. That you can see that it's animated, and every time when I shoot asteroids, new ones will get spawned. Oh. Every time I shoot an asteroid, a new one will get spawned in about one second. So eventually I'll be able to get asteroids all the time. And if I get destroyed, then I'll also get an explosion and it will be respawning. Okay, so actually that's about it. So we're kind of finished, but if someone else still has some questions, it's time for questions. Okay. Anyone? Okay, then I think we're finished.